Dear students, welcome to the lecture series on the topic Engineering Graphics. So today we are going to discuss about projections of the oblique planes. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now the oblique planes are the planes which happen to be inclined to both the reference planes, that is horizontal plane and the vertical plane. Now let us see the order of inclination of this hexagonal lamina or the hexagonal plane with respect to the two reference planes. So let us read out the statement. A regular hexagonal lamina 25 mm side has a corner in the horizontal plane and its surface is inclined at 45 degree to the horizontal plane. So this means that this lamina is inclined to the horizontal plane in the first instance, and thereafter it makes an inclination with the vertical plane. So we are going to draw the top view of this lamina onto the horizontal plane first of all. So to begin with, we are going to assume that this lamina surface is first of all parallel to the horizontal plane, and if the surface is assumed to be parallel to the horizontal plane, so on the horizontal plane in the top view below the XY reference line, we are going to draw the projections of the line which will provide us with the true shape of this lamina, that is the hexagonal shape will be obtained. Then it has got one corner in the horizontal plane. So since this lamina has got one corner in the horizontal plane, so once you tilt it out, so it means that we are not assuming that this lamina is tilted at 45 degree, so this lamina will be contained by the horizontal plane. And if this lamina is contained by the horizontal plane, so its front view will be an edge view which will be obtained on the horizontal plane, that is onto the XY line. So the front view will be the edge view which will be drawn right on the XY line because the lamina happen to lie on the horizontal plane, whereas the top view will show the hexagonal shape, that is the true shape of the lamina in the first instance. Then the second rotation is, that is the plan of the diagonal through that particular corner which is lying in the horizontal plane. It makes an angle of 45 degree to VP. It means that the angle beta is the angle of inclination of the plan of the diagonal or the apparent length of the diagonal, which is corresponding to that corner which is lying in the horizontal plane. So it makes an angle of 45 degree to the VP. So that is the second iteration that we are going to draw. So based upon these two inclinations, we are required to draw the projections of the lamina. So now let us first of all work out the correct orientation of this lamina with respect to the XY line. So let us pick up this particular case orientation. If we draw the hexagonal lamina in this orientation, then what will happen? Below the XY line, that is the top view, will show this as our true shape, and in the front view there will be edge view which is lying on the XY line. So if I pick up my edge view either from this side or from this side, so that the surface of the lamina is inclined at an angle of 45 degree to HP. So even if I incline it this way, my corner of the lamina will not be resting on the horizontal plane. Even if I lift my edge view with respect to a horizontal plane at an angle of 45 degree, again my lamina will be resting onto this edge, not on the corner as it is indicated over here in this problem. So this case is totally rejected. So what we have to do, we have to draw this hexagonal lamina into this orientation below the XY line. Why? Because if I draw the hexagonal lamina in this orientation and in the front view there will be the edge view, whether I lift this edge view from here, this corner 45 degree to HP, still my hexagonal lamina will be resting on horizontal plane on one of its corner. Otherwise also if I lift it this way, then again it will be resting on the ground or on the horizontal plane on the corner. So that is why this is the correct orientation of the hexagonal lamina that we have to draw on the horizontal plane and below the XY reference line. So let us start with construction of the hexagonal lamina projection. So this is step number 1. So we have drawn the true shape and we are going to mark all these points A, B, C, D, E, F, and the edge of this hexagon is 25 millimeter. So edge has been drawn as 25 millimeter. So having drawn this, we have obtained the true shape of the lamina on the horizontal plane in the top view, which is the true shape of the lamina. Now let us draw the front view. Since the lamina has one corner in the horizontal plane, and when the lamina is parallel to HP, so obviously one corner in HP means that this lamina is contained by the horizontal plane. So let us draw all these projectors through all the points or the corners of this particular hexagonal lamina in the top view. So point A will be projected here as A dash. Point B and F, they will be projected here as B dash and F dash. Points C and E, they will be projected in the front view as C dash and E dash. Point D will be projected in the front view as D dash. So the front view of this lamina happens to be an edge view. Since this lamina is contained by the horizontal plane, so it is perpendicular to the vertical plane. And since this lamina happens to be perpendicular to the vertical plane, so projection in the vertical plane in the front view will be an edge view of the lamina. So having obtained the edge view of the lamina in the front view, now we need to incline the surface of the lamina at an angle of 45 degree to the horizontal plane. So let us do that. So all these points we are going to transfer it over here at an angle of 45 degree. So please see, we are going to mark these distances over here, and same distances will be transferred in the view number 3. So first view is true shape, second view is the edge view, third view is rotation or translation. So same figure, that is same edge view with all these points marked over here, will be rotated at an angle of 45 degree. So having made all these markings over here, so we obtain A1 dash, B1 dash and F1 dash, they are obtained here. C1 dash and E1 dash points, they are obtained over here, and D1 dash is located over here. Then we need to obtain view number 4, which will be our corresponding view. In order to obtain the corresponding view, vertical projectors from this elevation view and the horizontal projectors from this plan view we have to draw. And wherever all these points, their corresponding points, they intersect, we will be carrying out the marking of all these points. So here you can see A1 dash and A. So wherever these vertical and horizontal projectors they intersect, you get the location of point A. Similarly, B1 dash and B, wherever they intersect, you get the location of point B1. C1 dash and C, you get the location of point C1. Then the intersection of locus line of the vertical projector from D1 dash and the horizontal projector from point D gives you D1. Finally, you get E1 dash vertical projector intersecting with horizontal projector from the plan point E, giving you E1, and F1 dash vertical projector intersecting with the horizontal projector of F, giving you the F1. So having located all these points, we have been able to draw the top view of the lamina, which is inclined at an angle of 45 degree with respect to the horizontal plane. And we can very well observe through this construction that this shape is an apparent shape and it is smaller than the true shape of the hexagonal lamina. And over here, another thing you can observe, all these edges of this lamina have been reduced because none of the edges of this lamina, they happen to be parallel to this horizontal plane. So since none of these edges, they were parallel to the horizontal plane, and all the edges, they are inclined with respect to the horizontal plane at an angle of 45. So we have observed reduction in all the 6 edges of the hexagonal lamina. So this has been foreshortened from all these edges. Now having drawn this top view, now the next phase is that we have to transfer this plan at an angle of 45 degree to VP in such a way that the diagonal through this corner, you see this is a corner on which the lamina is resting onto the horizontal plane. So since the lamina is resting onto the horizontal plane at this corner, that is corner A1, and the diagonal is this one, but this is not the complete diagonal, the true diagonal is this. So here it is the apparent length of the diagonal or the plan of the diagonal which has been observed, and we have been provided with this angle beta. So beta is the angle of, that is the diagonal through this corner which is in HP makes an angle of 45 degree to VP. So you have the plan of this diagonal. So the plan of the diagonal is A1 D1, which is reduced. So A1 D1 is lesser than, it is shorter than the original diagonal which happens to be AD. So this is the plan of the diagonal. Since this is the plan of the diagonal, so it is inclined at 45. So we can say that the angle beta is equal to 45 degree. So this picture or this plan projection has to be transferred at an angle of 45 degree, where A1 D1 we have to locate at an angle of 45 degree. So let us do that. So here you see we have drawn projection line at an angle of 45. So this figure we are going to transfer with respect to A1 D1, that is A2 D2 will lie here, and once again the rectilinear distances we are going to measure and locate all the rest of the point. So here you can see again we are going to mark 4 points, point 1, point 2, point 3, point 4. So you see point 1 has been marked, then you can have point 2 over here, point 3 over here, and point 4 over here. So since 4 points we have marked, at point 1 the vertical distance is 0, point 4 also vertical distance is 0. So A2 and D2 will be located over here. Just see straight away A2 and D2 will be located because the vertical distances from first and fourth point they are 0. From second and third points I will measure only one distance, that is this much, because this distance is equal to this distance, and distance of C1 is equal to distance of E1 from this diagonal. So distance of F1 is equal to distance of B1, distance of C1 is equal to distance of E1 from this diagonal. So measuring only one distance is enough. So from second and third point locus line, just see, second and third points locus line will draw 4 distances: distance of F2, distance of B2, distance of C2, and distance of E2. And this figure will be reconstructed at an angle of 45 degree. That is, this plan of the diagonal is being oriented at an angle of 45 degree with respect to the vertical plane. Now I have I have taken out these guidelines, that is construction lines, because they were required only to transfer this figure over here. Now the next thing is, having obtained this top view of this lamina which is inclined to both HP and VP, now I need to evaluate the front view of this lamina. So once again, as usual, figure 5 was our translation or rotation of the figure 4, and figure 6 will be the corresponding figure. So here we have 6 points of this hexagonal lamina projection. So all these 6 points, they will be projected upwards, and these 6 points we are going to project from left to right. So once we project these points left to right, so wherever the corresponding points of intersections will be there, so we are going to have the location of the points in elevation. So just see, this is vertical projector from A2, this is horizontal projector from A1 dash. So this will give us the location of the A2 dash. Similarly B2, so this is vertical projector from B2, this is horizontal projector from B1 dash. Wherever these two intersect, we get the location of the point B2 dash. Similarly C2, so this is the vertical projector, and this is C1 dash, this is the horizontal projector. Corresponding to D2, just see, this is the vertical projector and this is the horizontal projector corresponding to D1 dash. This gives us the location of D2 dash. Similarly E2 vertical projector and E1 dash horizontal projector, wherever they intersect, you get the location of E2 dash, and finally F2 you have the vertical projector, and F1 dash you have the horizontal projector. So wherever these points they have intersected, we have labeled these points and then we have joined these points. So this gives us the front view of the lamina, which happens to be inclined to horizontal plane with an angle of 45 degree, and the plan of the diagonal through this corner at which it is resting, it is making an angle of 45 degree to the vertical plane. So using 6 steps we have been able to work out the front view and the top view projections of this oblique lamina. So these were the projections in front and top view. So I hope with this illustration you have been able to understand that how you can go about constructing the projections of the lamina which happens to be inclined to both the front view and the top view. So thank you very much. Thanks a lot.